Okay, as we're looking at section 6.4, our goal today, is to determine when the graph starts, is it up high or down low? And when the graph ends, is it up high or down low? That is called end behavior. All right? End behavior. When it starts and when it ends. Now, I want to keep this really, really simple. I want you to think of the most basic graph of y equals x squared. What shape is that? What is that called? A parabola. And would we all agree that it looks like this? I would call that, Michaela, ending high and starting high. Now, in comparison to that, Rebecca, negative x squared. That's an upside down parabola, right? So how would you guys describe that? It starts what? Starts low and it ends low. So that's what I mean by end behavior. You with me? Okay, so here's what we're going to do. I need everyone to go to their graphing calculators if you have not already, and I want everyone on our graphing calculators to set your window to negative 5, 5, and negative 20, 20. So if you don't understand what I'm saying there, go to Window and look at my window on the screen. You see how it's negative 5 to 5 and negative 20 to 20. Now, you might notice down here on Y scale, I made my scale 2. So I didn't want to have 40 tick marks going across my screen. So I try to reduce so I just have to remember in my mind, each of my tick marks is 2 on the horizontal, but 1 on the vertical. We all good there? Does anyone not have that done? All right, so let's go back to our notes. We're going to do a little divide and conquer here. Okay, Luke, I want you and your row to do example 1. Lauren, you and your row do example 2. Now don't start yet. Trevor, you and your row, example 3. That means Alejandra, your example 4. Peter, your example 5. Krista, your example 6. Mas, your example 7. And I want everyone to do example 8. This is what I would like you to do. I would like you to plug in your equation on your calculator. I would like you to tell me what is the degree of that equation. In other words, the highest exponent. What is the leading coefficient? I will highlight that on number 1. The leading coefficient of this first one is 2. The leading coefficient on the second one is the number in front of the x to the 4th. Get the idea? And then I want you to do a basic sketch of the graph, and then tell me what is the end behavior. And what you're going to say, Joey, is you're going to say something like this. Whoops, that's in highlight. You would say something like arrow down, which means starts down, ends up. Make sense? Okay, now I don't know if that's the answer for this one, so I'm going to erase that. But that's how you would classify the end behavior. So you're going to fill in the first 4 columns. This should take you about 3 minutes. And then we're going to summarize and look at each of the graphs. So go. I will be doing that while you are doing it as well. We all doing okay? Have you finished both of them yet? Make sure you did the first one and the last one. How's that butter burger?
Not spicy, so that's good.
Are you a not spicy guy?
Yeah.
You're like my daughter.
Was it buttery?
It was very buttery.
You guys are just all jealous.
Buttery, you know.
It better be.
How the fries?
Oh, they're really good, yeah.
All right. Okay, I've done my best as I possibly could to sketch them. I just need some clarification. Rebecca, would you agree that that's the sketch of number one?
Yes.
Second row, does that look close to what you have?
Yep.
Third row? Okay, fourth row.
Yeah.
Okay, so everyone copy down those sketches on your graphs. The fourth one's my favorite. It reminds me of Bart Simpson's hairdo. Who knows Bart Simpson? Anybody? Okay, that's the Bart Simpson hairdo, you know. It looks better on the actual graph. I didn't do a very good job of mimicking. So everyone copy down those graphs, and then we're going to do some learning from this graphing exercise. Everyone have them down? So let's go. Degree, first row. What's your degree?
2.
It is 2. Our degree is 2. What is your leading coefficient? What I highlighted in yellow. 3. And would you agree that is a positive number? It's an obvious, because I can't write.
Okay.
All right, row 2.
It was really good.
Row 2. What is your degree, Mr. Froese? What is the number on the x to the 4th?
1.
Okay, so we got a 4. Degree is 4. What is the leading coefficient, the number in front of the x to the 4th?
1.
Invisible 1, and would we all agree that is positive? Please put a plus there. It's going to make a difference later, trust me. All right, row 3. Joey, what is your degree? 2. Kylie, what is your leading coefficient?
4 or negative.
Negative 4. We'd all agree that is a negative number. All right, 4th row. Sebastian, Annalise, and Alejandra, what is your degree? 6. And your leading coefficient? Negative 3. We'd all agree that that is a negative. Okay, now. End behavior. Would you agree this first one starts up and ends up? And the second one starts up and ends up. True? Third one. What does it do? Starts down, ends down. Fourth one. Starts down, ends down. Now, I'm going to change colors to green. I'm going to put a dot there, and that's, I would think you would all agree, that is a relative minimum. True? Bottom point. So at that point, the graph turns. It goes from going down to going up. So we call that a turn. So this has one turn. Okay, our second one. I have a relative min, a relative max, and a relative min. How many times does my graph turn? 3 times. Okay, 3 turns. My next one, how many turns? 1 turn. My next one, my Bart Simpson hairdo. Turn 1, turn 2, turn 3, turn 4, turn 5. 5 turns. Okay. Sign out at the front office. Do you want to make any conjectures based on what you see on this screen at this point? We're talking generalities here. Trevor?
Were you saying the number of turns correlate?
How?
-1.
Do you agree with him?
Yes.
Okay, so the number of turns is 1 less than the degree. Spot on. Well done. Any other correlations?
Negative. They start down.
Negatives. They start down and they end down. Great correlation. Well done, Flounder. What's that? See what I'm doing there? You catching what I'm throwing down?
I do.
Huh? Little bait. Little bait. Another correlation.
Can it be that the plus ends and starts with plus and goes up?
Plus starts up, ends up. I don't know how many are in that box. So, when they're gone, they're gone. All right, so would you say that's a summary of those? So that leading coefficient becomes fairly important, true? Mm-hmm. The leading coefficient is going to drive, that's going to drive the up and down piece. Now, how do we remember that these start up? Well, we go back to our granddaddy of all functions, the parabola. And we all know that a parabola starts up and ends up, right? So if you're trying to remember the pattern, think back to a regular parabola, starts up, ends up. What is the degree of a regular parabola? 2. And we all know it starts up and ends up. How many turns does a regular parabola have? 1. Okay, so our first 4 rows, great job. Let's shift to page 2. Here we go. Now, copy down those graphs. Take a minute, copy down those graphs. They're just sketches. I'm not really worried about x-intercepts and y-intercepts here. I'm just looking for sketches. So copy those down. And now let's do some analysis. All right. Peter, Jessica, and Stephen, what is the degree of number 5? 3. What is your leading coefficient? 1. And we do agree it's a positive. Row 6, Krista and Mia, what is your degree? 5. And what is your leading coefficient? 2. And it is a positive. Number 7, Mas and Greg, what is your degree? 3. And your leading coefficient? Negative 4. So that is obviously a negative. And who can do number 8? What is my degree? 7. Leading coefficient? And so that obviously is a negative. All right. Would we agree that our turns still go with the rule of Gömel?
Yes.
3 minus 1 is 2. 1, 2, 3, 4. 5 minus 1 is 4. 1, 2. 3 minus 2 is 1. I must have graphed it wrong. Let's go back to the graph. Y equals down, 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 all the way down to where Flounder lives. Under the sea, down where the flounders dancing arounders. Take it from me. All right. I feel like there's only 2 terms there. Would you agree?
It's really small.
Really small.
Like really small. There's like a bunch of tiny ones. That'd be very impressive.
Small.
Yeah.
Dude, I'm going from 1 to -1 there. I mean, that's looking pretty curvish to me. You know? I'm not seeing multiple terms. So, what can we conclude?
It doesn't always work.
All right. So would you agree that the number of turns, even though the number of turns is 6, we might have some multiple answers here? Like we did on this one, number 14, where we had multiple zeros at different numbers. Is that possible? Just per se? Yes.
You put 1 instead of 2.
I put 1 instead of 2. Where? 7. Oh, you are correct. I should have a 2 there. Thank you, Miss Krista. Star for the day.
Hey.
Oh, you're fun.
All right. And behavior. Here we go. Would you agree starts down, ends up? Starts down, ends up. Starts up, ends down. Starts up, ends down. Give me some brilliant deductions. Come on. You're out of play. Lane?
If the leading coefficient is positive, it's going to end up.
If the leading coefficient is positive, period, it's going to end up. Let's take a look. Going back to page 1, leading coefficient is positive. Do they end up? Leading coefficient is positive. Do they end up? I like that. That's pretty good. Have you gotten something yet? All right, going in here.
Hey! Let's go.
Yeah,
I have a question.
you have a question? Go.
Where you look back at the worksheet,
Uh-huh.
if you, this is about homework.
Go.
You can't find the error in that sheet right there within 30 seconds. We don't have homework. It's a big one. So like you'll probably get it in like 2 seconds.
1, 2, 3, 4, 5, 6, 7,
Oh,
5,
what am I looking for?
An error.
12,
An error?
13, 14, 15, 16, 17, 18.
Is it something that's written small that I can't read?
No, it's pretty big.
It's written pretty big.
25, 26,
What did I miss?
27, 28, 29.
No deal.
I'm no
Dang it. I'm not gonna.
What did I miss?
Those 6.
Oh.
What do you mean?
There's only 2 turns.
Well, that's my point. That's the whole point of this discussion. I realize there's only 2 turns. That's the whole point of our discussion. That's what we're talking about. All right. So what Joey's trying to bring up the fact is, why is there only 2 turns when actually there should be 6 turns? And my point is this. Back to number 14, we had a multiplicity here of multiple possible roots. And so the number of turns is the maximum number of turns. Okay? It's either going to be 6, 4, or 2. Okay? Either 6, 4, or 2. It's going to go down in multiples of 2. Because it has to start low and end high, or start high and end low. So you have to have 1 less and then off of 2's. So theoretically, this one that had a degree of 5 could have either had 4 or 2 turns. The 3 could have either had 2 turns. This could have either 6 turns, 4 turns, or 2 turns. Does that answer your question?
Was that close to getting us no homework?
No. But nice try. Keep going.
Well,
You were floundering a little bit there.
was that?
Yeah. All right. This is just going to be a good season, I sense. All right, so let's summarize what you guys just all said. I think you did probably a fantastic job. If there's an odd degree, all right, remember an odd degree looks generally like that. So if it's positive, it's going to start low and end high. All right, it's going to start low, end high. If it has a negative degree, it's going to start high and end low. So start high and end low. That's if it's odd. Now, I want to give you the granddaddy of all odd functions. Y equals x. Would you all agree that it starts low and ends high? Because it's positive, right? All right, let's look at our even degrees. Even degree, positive coefficient, starts high, ends high. Negative coefficient, starts low, ends low. I love what Lane said. The leading coefficient tells you where it ends. If the leading coefficient is positive, it ends high. If the leading coefficient is negative, it ends low. Lane, you don't have any concept of how clear that was that you said. That was a very clear explanation. All right, so the degree of the polynomial, by the way, this is the law of Gödel, determines the maximum number of what? Terms. Now, going back, Flounder, to your comment, what does that say there? The maximum number. Okay, that's why it didn't have 6. Okay, and the maximum number of zeros or roots on the graph. I hope you realize that zeros and roots are the same thing. It's where the line crosses the x-axis. So, let's go back to the law of Gödel. The maximum number of turns is degree minus 1. The maximum number of zeros would be what? What's the maximum number of zeros? You want to look back at the graphs? How many zeros does this one have? Let's do those in purple. 1 0, 2 zeros, 3 zeros. And what was the degree? 3. Let's go up here. 1 0, 2 zeros. What's the maximum number of zeros? It equals the degree. Okay, the maximum number of zeros equals the degree. Why might you not have some zeros? They might be imaginary. We've done those. That's what we did in section 3 and section 4. So let's draw some possible graphs for a 4th degree. The most classic 4th degree with 4 zeros would look like that. 3 turns, 4 zeros, all real numbers, beautiful. However, we might get a little weird. You know, like that. Are there still 3 turns? But how many zeros? 2. Or we might get something that actually looks like this. Even though it has a degree 4, how many zeros? Maybe only 1, maybe 2. How many turns? 2. Your turns is always one turn. It's always going to be 1 less than your degree, or that minus 2, minus 2, minus 2, minus 2. So those are just some possibilities for a 4th degree. That make sense? So we have a very short worksheet for homework. It's multiple choice. Okay, so let's just jump to that just for a second. Let's take a look at what it is so we can make sure that we understand what we're doing. All right, so here's our homework. You're not going to do it right now. You have 4 sections. Here you're going to talk about end behavior and talk about how that works with these graphs. Section 2, I want you to notice all of these leading coefficients are negative. So based on the law of Froese, where do they all end? Down. Look at section 3. What do you see similar about these right here? They're all what? No. What are they all? 5, 3, 3, and 5. They're all odd. Notice, that means they all start in one direction and end in a different direction. What about 13 through 16? What are they all? Even. And then down here, by the way, if it has 3 factors, what's the degree? 3. 3 factors, 3 factors. So what are you really focusing on? The numbers in front, all right, positives or negatives. And then remember, like this right here, that means x equals 3, x equals -2, x equals -1. So I'm just trying to draw some graphs that might relate to those. Okay, so you're just making good judgment calls based on end behavior, roots, and terms. It should be a very straightforward homework assignment. It should take you maybe 10 to 15 minutes at the most, and you're going to do that after you take the quiz. Okay, so clear off your desks if you would.